Okay, this next page is about graphing of trigonometric functions. Why I required you guys to have a TI-30XS multi-view calculator and not a traditional graphing calculator like a TI-83 or 84. What's the point of buying a $150 calculator when this $15 calculator works for the hands-on evaluating, and then to graph we can use a free tool called Desmos. I will let you know on the tests you will not be using Desmos because I will not be requiring you to graph by hand on the tests. So if it's a question that requires a graph, the graph would be provided for you. And if it's a question that says verify graphically, you just wouldn't verify with the graph. You would just do the algebra and use your algebra to get the answer, not the graphing calculator to get your answer. So rest assured, when I give you the tests, I know that you do not have access to graphing software. I know that you do not have a calculator that has graphing on it. So I am aware of that, and I design your test based off of that. However, that doesn't mean, for instance, I'm a very visual learner. I want to know why things are working and how they're working. I like to see it. So that doesn't mean I'm not going to use any graphing this semester. I'm actually going to use a lot of graphing for verification this semester. And anytime I graph something, I'm going to be using Desmos. It's a wonderful free app on your phone, or you can even on your computer go to desmos.com. So I highly recommend downloading Desmos. I talked about this in some of the other reviews that we looked at, especially the lines and functions review. So here's what Desmos looks like. And so what I did was I went through and I wanted to graph each of the graphs of all of the trigonometric functions: sine, cosine, tangent, secant, cosecant, and cotangent. I tell you exactly what I did, what I set it up on. I set my x-axis from 0 to 2 pi. I set my y-axis from -1 to 1. Notice my step is 0.5 on my y, and my step is pi over 2 on my x-axis. So that's what I set my settings at, which are on the top right of the page. And then I just typed in sine of x. It gave me the graph, and boom, that's what it looks like right there. So what you're going to do is this exact same thing. You want to do it for sine. You want to do it for cosine. You want to do it for tangent. Do it for cosecant. Remember, cosecant is 1 over sine. Do it for secant, which is 1 over cosine. And do it for cotangent as well. Pretty cool to see those graphs done so easily, but I want you, when you specifically look at these, I want you to consider things like, what are the domain of the graph, the range of the graph, where are those x and y intercepts, could you label the points on the graph? So what points do I care that you label? I would really care about these on sine and cosine. It's these 5 points that I really care about that you know. For instance, 0, 0 is 1. Pi over 2, 1 is another point. Pi comma 0 is a point. 3 pi over 2, -1 is a good point. And then 2 pi 0 is another important point. So these are 5 points that I would always expect you to label on the graph. Same thing with cosine. I would always expect you to label those corresponding 5 points. With tangent, cotangent, secant, and cosecant, I wouldn't expect all of these points to be labeled, but I would expect your vertical asymptotes to be labeled and at least 1 point in each one of the periods. So try to remind yourself, what do the graphs of these functions look like? Sine, I think of an S. Cosine, I think of a cup. If you look at the graphs, you'll understand what I'm talking about. But please take some time, go into Desmos, enter all of those graphs, label some points, and graph them by hand now.